Welcome, everyone. We'll be talking about Galapagos tonight. But if anyone, since the comments were, oh, what a beautiful weather we're having, if anyone was thinking, oh, is there any place we could get out? Why, yes, yes. So tomorrow we're doing our monthly walk along the Heritage Trail at 4 p.m. So I've been trying to do that the first Tuesday of each month. So where the Heritage Trail meets 6.5 Station Road near those Healy car dealerships. We'll be starting and looking to see what birds we could see. The swans, their eggs have finally hatched. They had 8 cygnets as of a couple of days ago. They were still there, so that's a lot. So that'll be fun to see. We have one thing in the chat. Can't hear you. All right. That's a fun. All right. Can anyone at home hear me? Oh, now you can hear me. Oh, good. Okay. Good. So there's that. And then this Sunday at 10 o'clock, I'll be doing a bird hike at the Bashik Hill at 10 a.m. near the winery. So if anyone was thinking, oh, I've been cooped up too long, I'd like to get out and look at wildlife, there are certainly those opportunities. Thank you for coming tonight. So this is part of a series which just popped up at the last minute because the spring series was so successful. We thought, let's do some more in the summer. So for the first half of summer, we're going to focus on biodiversity, not in Orange County, in our area, but in other places throughout the world, particularly the Americas, to see what's similar, what's different. So Galapagos Islands today, wildlife of Latin America. I lived in Paraguay for 2 years, and I visited a couple of other places. The Everglades, the Caribbean, and coral reefs. So a bunch of national parks plus some scuba pictures the week after that. The geological history of and biological diversity of the U.S. Southwest, focusing on a number of national parks out there. And then Nature Rocks, a musical evening on June 30th. You'll laugh, you'll learn, you might sing along. So you've gotten a preview of some of those. If anyone's interested, just because I teach a lot of classes and I thought, I love talking. So if any of these were of interest, we already talked about the biology of gender, but in the second half of the summer, we're going to talk about human blood and blood tests, the human heart and the ECG, human brain and behavior, and then some other systems. Just if anyone was interested in more things than just, birds and biodiversity, there's some talks there as well. Okay. So tonight's talk is about the Galapagos Islands, which I visited, and as a biologist, this was just as, as important a journey as one can make. And I can say that my father, who was a school teacher, brought home these reel-to-reel videos on the Galapagos Islands. And that was our entertainment as a family, the movies you could borrow for free overnight and return first thing the next day. And so the one on the Galapagos Islands, I'm sure, made an impression on me at an early age. I want to talk about the wildlife, but first, let's just talk about islands and where they came from. Would you find dinosaur fossils on the Galapagos Islands? And the answer is, of course not. Their maximum, I'm sorry, I'm just going to mute someone in the background. Maximum, they're about 5 million years old. And so the dinosaurs were long gone here. So if you were to look at the Galapagos Islands, they're young, all right, less than 4 million, 5 million years old. But this end of the Galapagos Islands chain is the oldest, and then they get a little younger and a little younger. So just this, we'll talk about the geology of the U.S. Southwest later, but this is kind of here. We think we know our planet Earth, but if you were to imagine planet Earth as an apple, we really only know the red skin, all right? The middle of it, there's stuff going on there, and we just don't get to observe that directly. One of the things that happens in the Earth mantle is every now and then in these currents, there are what are called plumes, where some mantle stuff flowing gets closer to the crust than it usually does. And if you have a tectonic plate moving, and here's a mantle plume that stays there for, millions of years, as the plate moves, some of this magma stuff then comes to the surface and forms a seamount underwater or maybe an island. But then the plate keeps moving, and then so you might find another island forming younger than that later. and then the plate keeps moving, and then you might find another island forming as it just passes over the same spot. So you've got a place of the mantle that's kicking up stuff, and as a plate slides over it, we see stuff here. And there are a lot of volcanic island chains. Let's take Hawaii, for example. How old is this island? About 5 million years. How old is this island? Well, this end of it is 3.7, this end is 2.6. And so we can see this like the Aleutian chain off of Alaska, where they all vary in age. And you can see, oh, the old ones start here, the young ones start here. So what we see in the Galapagos is kind of just how, all of these volcanic island chains start. And especially if they're fairly young, this affects then the vegetation, which will affect the wildlife, because the older ones, they've got trees. Right, they're so old that you're not like talking about bare lava anymore. That you've got, not only lichens and grass and cactus, but now it's got grass and trees, etc. But the younger ones, you will have less and less of that. So as you go from island to island, you'll see very different plants, and so you can have different animals on each one. So this is just some background into islands in general, since we're going to be talking about the Galapagos. All right. Now, I was playing the sea lion thing. Like, just there are so many ways we could talk about the Galapagos Islands. It's just wonderful. I mean, just the biodiversity is beautiful. We are on islands in the Pacific. That's beautiful. I've been on certain places where like we do hikes like the one I'll do tomorrow, where I'll say, everyone, here, get your binoculars. See that spot over there? That's a yellow bird. Does everyone see it? Or whatever. You go to the Galapagos and the animals there, they're not afraid of you. So like the sea lions will literally come and play. Like, so you'll snorkel and you'll be like, oh, like I hope I see a sea lion. They see you first and they come and they start swimming around you to play, right? It's amazing. And then, and like if I'm looking here, you're like, oh, there's a marine iguana as I snorkel swimming by me here. And all of a sudden you're like, oh, there's this big green sea turtle right next to you. It just, so it truly, it's amazing. But in addition to just telling you about this great wildlife, I'd like to weave it into a narrative if I could, because the Galapagos Islands are important for our understanding of biology. And I'd like to tell you why, as we talk about these great things. Now, I'm going to start off with something that it probably won't impress you. All right. But nevertheless, it's really important. All right. So if you were to read from Charles Darwin's book, The Origin of Species, which, changed biology forever. If you were to pick like the two big ideas that had more influence on biology than anything else, it would be Mendel and his inheritance and Charles Darwin. Charles Darwin, he says stuff. Sorry, that's me trying to do a Charles Darwin accent. All right. One of the big things, all right, now if I shock you, all right, feel free to express your shock any way you see fit. All right. Charles Darwin makes the argument that the pigeon is actually descended from the rock dove in the wild, from wild doves. That's how we get the rock dove.
Okay.
Okay. All right. Good. Pretending to be shocked there. So if you're not shocked, I need to just explain before we go back to the Galapagos. That was shocking when he published that. All right. That changed most things. Now, to be fair, there have been two ideas about how life on Earth came to be, going back to the ancient Greeks. The very first time people wrote down what they were arguing about, so people have been arguing forever, I'm sure, but philosophical debates have only been written down on things which have lasted to modern times, starting with the modern Greeks. Thales was the first, Anaximander, Anaximenes, and other ones, Epicurus, Democritus. Evolution was what they were arguing. Evolution versus design. How did this life come about? Did it appear in this form, designed, or did it gradually change to look like that? That is the oldest philosophical debate that we know of. All right. And, in some corners still going on today. So Darwin certainly did not invent this. All right. It kind of fell out of favor in the Middle Ages for a while because you could be killed for some of your thoughts on this. But when Darwin weighs in, the thing that he does that's different is he backs it up. He's had collections and observations all throughout the world, and he can not just reason about it the way the Greeks would. They said, oh, logically, think this is what's the case. He would say, no, I posed this, and here's the evidence with the barnacles I studied. He spent a lot of time studying barnacles or whatever, but he spent 5 weeks on the Galapagos Islands, only 5 weeks, but they were important, and he has his collections from there, and so he publishes. At the time, most people believed that when you look outside the window, that is how life has always looked. Right? That if you were to go back to the beginning of life, there were oak trees and blue jays and people and dogs and mourning doves and red ants and whatever else you see. That's what most people held. All right. As a result of what I'm about to talk about, Darwin changes that and says, no, there's another way that you could get this. These things could have changed over time. So as I talk about the wildlife that you could see in the Galapagos, I want to weave that into the narrative, just so that we see how the fact that you weren't shocked just shows you how influential this was. You've accepted that, of course, pigeons have descended from doves. Of course, they're related. All right. Of course, cats are a group related to each other. That was not what the majority of people held 150 years ago, but it was the influence of Darwin's insights, many coming from the Galapagos, which have just changed the way we look at the natural world. Okay, so right. So once again, I'm going to start off with what I kind of think, maybe exciting. You can feel free to, once again, react however you see fit. If you were to go to the Galapagos, which, by the way, there's lots of different ways to do it. You can kind of do it on your own, but National Geographic works with a shipping company called Lindblad, and National Geographic Lindblad, they have excursions. So if you said, like, I don't want to deal with visas or finding that, places to stay or whatever, I would just like to them to take care of everything, and then for the expert to say, all right, everyone, you're meeting at the boat at this time if you want to go snorkeling. That's just a great way to go. So just a little plug for that. If you were to go to the Galapagos, you see great lipped blue herons, and you know what's exciting about them?
Big.
They're the same as you'd see here. All right. So not all that special. Just, they fly all over the place. Some of them flew right to the Galapagos Islands. We don't have to mention them anymore. All right. And then here's a great egret. Same thing. All right. Oh, and these herons, actually, I might make a case for those herons. I'll get back to you. All right. But here we see oyster catchers. You can find them in the Jersey Shore. Here's a whimbrel. Same thing. All right. While boobies are famous for being in the Galapagos, you can find them in California. All right. And so not everything that we see in Galapagos is special. All right. Because especially birds that fly or, things that swim, they can get to these various places. Now, the Galapagos is often important to them because of the lack of many predators being far away from the mainland. So, for example, the great frigate bird, which you can see if you go down south, for example, here, this is an important breeding area. So if you were to go to the Galapagos, once again, you're just walking by. All right. So like, everywhere else is like, look, I can see frigate birds nesting over there. No, it's just like they're right there. All right. And there you'll see the males distending their throat patch. All right. There's two different kinds of a frigate bird in the Galapagos. But here they are, the males are all sitting there and the females are flying over, deciding like, do I feel like stopping? Do I not feel like stopping? So you can just kind of watch that play out here. So this is cool to be this close to frigate birds doing their thing, but evolutionarily, it's not special. These are the same old frigate birds which we could see in other places. Now, for my students, I just kind of came up with this to kind of put a synopsis on that. We know that things vary. I mean, everything varies. I mean, we can see it in our dogs. We can see it in, our flickers. There are the yellow shaft or the red shaft. I could go on. But if you were to look at sea turtles, some are yellowish and some are black. And it's just like two different, breeds of dog. All right, just like, these dogs can vary, so can these sea turtles. Look at these lava lizards. These aren't different species. They're just different color morphs. This one's a little darker. This one's a little lighter. If you were to look at red-footed boobies, there are 3 kinds of boobies in the Galapagos. They're the same species and subspecies, but this one looks a little lighter than other, just different, shades here. So things vary, and that's not a species or a subspecies. It's just a different color morph. However, if you're on islands, and I'm sorry, just getting back to this is not exciting. All right, so like these are the same old Annie birds that you can see elsewhere. Same thing here, same thing there, same thing there, same thing there, same thing there. Right. Oh, okay. No, we're okay. However, because you're in islands and you're far away from the mainland, if things vary and you've got variations over here and variations over here, and they're really not communicating with each other all that much, now all of a sudden you can see what we call a subspecies. Different. Now, once again, this is something that you might have accepted. But once again, in Darwin's day, that didn't happen. They were going to stay the way they always were. All right, I hate to get into philosophy, and I'm going to say this wrong. So if anyone wants to correct me, feel free to correct me. Any like Plato experts in this room? Right. Or if you are, feel free to correct me, because Plato, who Western civilization loved, would have said, like if you said, you see that gray squirrel out there? No, no, you don't. That's really not the gray squirrel. Like, so imagine in a cave. All right, so you're in a cave, you're looking at the back wall, and there's a fire behind you, and someone walks between you and the fire. You see their shadow. Do you see the person? No, you just see the shadow of the person, not the essence of the person. The essence of the person is behind you. You don't really perceive that, so the shadow isn't the thing. In the same way, that's not the gray squirrel. The gray squirrel has like this otherworldly essence that is its true gray squirrel stuff. That's not the gray squirrel. So this gray squirrel could never change because that's not really the gray squirrel. The gray squirrel essence is elsewhere. Right? That's about as good as I can do. If anyone wants to add to philosophical depth, feel free. But okay, you had your chance. But that's what people thought. So the idea of things changing over time, that wasn't a thing. All right, people just said, no, life was created. It looks like this. It will forever look like this, exactly this way. That's what was held. But now, if you go to the Galapagos, you have brown pelicans. They're the same species of what you can find in Western South America, but now they start to look a little different. All right, that we recognize them as different subspecies. So let me just show you a bunch of um, those, and then we'll get to all the species and the cool ones. All right, so flamingos. We can see flamingos a lot of places, but the ones in the Galapagos, they're a little bit isolated from the ones you don't find outside the Galapagos, to the point where it's recognized as a subspecies. They're starting to change relative to the flamingos we see elsewhere. I'm sure a lot of you know yellow warblers, all right, if you've been on bird hikes, et cetera. This is a yellow warbler. All right, same species as what you look at. But if you know your yellow warblers, you're noticing like yellow warblers don't have like red heads, or like palm warblers do, but not yellow warblers. All right, so that's weird. And then some of these, like that's gray. Like in our area, yellow warblers aren't gray. My point is, that's a yellow warbler, just like the yellow warblers you see, but it's different. I mean, if you know yellow warblers, that's not what our yellow warblers look like. That's what the Galapagos yellow warblers look like. So it's recognized as a different subspecies. It's changed. All right. So still consider the same species. They could still reproduce together, but you could tell the difference between their uh, yellow warblers and ours. The noddy tern, same thing. There's a subspecies on the Galapagos, and it's like a dark gray to black. And actually, that's going to pop up a lot here. Why? Because we've got islands with lots of black volcanic rock. So if you want to, camouflage yourself, from predators on black volcanic rock, obviously, dark grays and blacks looking at. So there's going to be a lot of dark things here. Yeah.
Given that they have such low predation, why do they need to be matching?
Oh, so there are. So for example, here is so I would never say they would have no predation. But so here's a Galapagos hawk. It's a species only found in the Galapagos. So hawks are not as common. In fact, I think this was the only hawk I saw. Maybe it's the only hawk that's there. I'd have to look that up. Yeah. So and they would have fewer predators than what they would experience here. Certainly a fewer diversity, but they wouldn't have no predators. And I'm trying to think of other native. I'm sorry, I'm just going to mute someone in the background if that's okay. I like there was, okay. Lately, I mean, humans have introduced like cats and dogs and other things, which are a problem for some. I'm actually, that's a good question. I'm trying to think of what other, um, if I think of another predator, I mean, certainly like seals and sea lions, like they can prey on some. Um, So here you can see that we can get different subspecies. This duck is the same species as another member in Western South America, but it is a different subspecies. Now, if you isolate them more, all right, so we isolate them even more than they already were, now, at a certain point, you can get to what we call a different species, where individuals don't reproduce well together. Now, this is messy. Now, that's going to frustrate you. It certainly frustrates me, but that's actually kind of the point. All right. It used to be thought that a species is kind of like this rock solid thing, that like species are immutable, that they never change, and like they're these discrete units. Whereas, are all of these different species or are they subspecies? Well, I could go through a lot of examples. You don't want me to, but like these used to be called different species. Now I think most biologists call them subspecies, but some still call them species, etc. I could do that with a lot of them. Like, ooh, this used to be a subspecies, now they think it's a species or whatever. The point is, the people who study this, they don't always agree. It's not as if you can just tell clearly a different species, clearly a subspecies. Because if you're looking at do they reproduce together or can they? All right. Well, if they're on different islands, well, maybe they could, but they tend not to have the opportunity, or we've never seen them do it, especially if they're in danger of extinction. Or what happens if they can, but they have to try really, really hard. All right. And sometimes they can, but their offspring are infertile. Point is, it's messy. It's not this black or white where they can or they can't. All right. So one of the most famous species in the Galapagos is the tortoise. Now, I lived in Paraguay. Here's a Paraguayan tortoise. This is actually a close relative of the Galapagos one. So somehow something that looked like this from South America got on an island. We'll never know how. I always say, like, there's a big storm, there's a big tree, floating out in the sea with an animal clutching on it, but who knows? And things swim that you don't think would. Like, I'm always surprised by who can swim. Like, elephants can swim, apparently. Like, people can be in the middle of the ocean and you're like, oh, there's an elephant swimming by. Like just, that's a weird, like, or if you've ever been in a canoe, all of a sudden, like, I've done this where you're like, oh, here's a deer just swimming the length of the lake. And then it gets out around the other side. I'm like, I didn't know they did that. So things swim that you wouldn't know. But anyway, I don't know how that got here. But a tortoise like that got here, and now without predators, got to be much, much bigger. Now, there are two animals on this presentation that really made an impact on Darwin, and it wasn't the finches. The finches are a beautiful story, but that comes later in Darwin's understanding. It was the tortoises and the mockingbirds, maybe the marine iguanas, although I don't know if he put it together. Certainly the tortoises and the mockingbirds. Not only do you say South America has something that looks like this, but not this big. Like, this is special. And he's thinking, how did it get here? And if you look closely at this tortoise, and then we will look at some of the other ones. Oh, and I'm sorry, this is just me by all of the, statues and things of Darwin, in the Galapagos. All right. Look at this shell. Can I ever see the different it is? All right. So if you were to look at these shells, like look at that one. All right, there's a bunch which are called the saddleback ones. There's different shells because on different islands, there's different types of vegetation. In some, the vegetation is much higher, and so a tortoise, which is a vegetarian, has to reach further. So the shell has a different shape so it can shape its neck. But anyway, someone told Darwin, oh, right, I can tell what island a tortoise came from based on the shape of its shell. Now, in Darwin's head, that doesn't make sense because everything was kind of like created the way it has always been and will always be. But why would there have been a tortoise created this way on this island, and then a little different on this island, and then a little different on that island, and a little like, just seems like an awful, like, inefficient way to do it. Maybe there were just tortoises that change on each individual island. Now, once again, to us, maybe not as revolutionary because his work was so influential. It's now through that lens that we view biological life. But this was revolutionary at the time. There were a couple of reasons. This is a whole nother lecture. But he will wait 19 years before he publishes his work. Like part of it was he was gathering data. Part of it was he was scared. All right. His grandfather, Erasmus Darwin. Oh, I love this guy. He was one of the most famous physicians of his day. King George III asked him to be his personal physician. He said no, which one doesn't usually say to King George III, in part because he was a friend of Franklin's and was like Benjamin Franklin's and the colony people, exchanging letters and the like. But Erasmus Darwin had the most important medical treatise, these two big volumes, but it was put on the forbidden uh, uh, list of books to read because in one little chapter he writes a poem where he muses maybe life changed over time, and that like the world's most prominent physician gets his book banned based on that. So Darwin was scared to say that things might change over time. This was kind of a very different idea back in the day. But you could go to different islands and then see different what used to be called species. Now they call them subspecies. I still kind of like species of these tortoises. In fact, on this big island, Isabella, you can see different species on the same one because if you've got a volcano here and a volcano here, these big tortoises, they're not really going over like this jagged like field of black volcanic rock. So these tortoises are isolated from those. All right, they're not really going to get together where they could mate, et cetera. And so you can actually have different species living on different parts of the same island. And we think they're different species because here's a sad story. This is Lonesome George from Pinta Island. This is the last tortoise from Pinta Island, a male. And these tortoises can live over 170 years. So George lived a really long time and was kept in, as it was famous all in the Galapagos, like all the school kids would go and see George. But there were no females of his species. They brought him females of all of the other things, but it just didn't work out. And that was the thing. Will they find on Pinta Island, like a female, that we could continue the group? But then when George died, that was the end of this subspecies or species of Galapagos tortoise. So, so they're iconic. But I got to go on because there's so much iconic about the Galapagos Islands. South America has iguanas. All right, one of these iguanas got to the Galapagos, and from this iguana came 4 species, 3 which live on land and are only found in the Galapagos. These are a lot bigger than South American iguanas. They can reach up to 5 feet with their tail, so they're pretty big. One is pretty common, the land iguanas. But then 2 are found only on small areas. One is in critical danger of extinction and has a pink face. I didn't get to see that, but there are these. But a 4th species evolved to be good at not eating plants or land, although it can, but rather eating algae and seagrasses. Mostly the green and the red algae, can't eat brown. Because plants in general are hard to digest, different kinds of algae are. So you have to have the right microbes in order to do that. And actually, their infants, one of the first things they do is eat the feces of their adults so that they get the microbial populations, which will help them digest their food. So in order to get this algae, they swim and they dive underwater. So this is me snorkeling, and there are lizards underneath me. A lot of the time they're going 15 feet down, but they can go as deep as 100 feet. All right. And while most of their dives aren't all of that long, they can stay up to an hour. All right, so here you can see what they love to do. All right, they're eating the green algae here. They've got strong claws, which help them grasp the rocks, which have waves continually breaking over them. Once again, you can get so close to them. And if you're snorkeling, they just swim by you. I was like, oh, okay, there's a marine iguana. I was like, oh, I hope I can see a marine iguana in the Galapagos. It's like, oh no, I think I could touch it with my head, So they're swimming along. It's got this flattened tail so that it can have a more Repulsion. Here you can see there's a bit of a current. Currents become really important in a second. So just notice that you can, like if you were snorkeling, you'd say, "Ooh, I have to work hard to swim against this." There's a real current I'm swimming against. So their claws help them here, right? So here's all of the marine iguanas, and I was lucky because I got to see all of those living marine iguanas. Had I been there the year before, I would have seen this. All right. Now, there's nothing wrong with this. I mean, sad, but just I was able to visualize something I had never seen done before. Like, oh, I've always heard of El Nino and La Nina. I've always heard about that, but like, I'm like, okay, I guess, but like here, all of a sudden, like, oh, I so get it now. Because as you get this flux in weather conditions, this affects ocean currents and affects rain. So when I was in the Galapagos, it looked like it was winter. We're like, "Ooh, what happened to all the trees? Are they dead?" No, they just have a dry season. They drop their leaves. Once it starts raining, they'll look green again. So on land, it just looked really arid, but it will look much lusher. That's what happens in La Nina years. In La Nina, less rain, so the land vegetation kind of suffers in a bit in the land habitats. But in La Nina years, you get these currents from the south that bring all these nutrients. So the algae bloom, the fish bloom, and the marine animals love it. So now you got marine iguanas everywhere, you got sea lions everywhere, you got Galapagos penguins everywhere in La Nina years. In El Nino years, the currents shift. And all of a sudden, now the food chain, just the bottom falls out. There's no nutrients, there's no green algae, there's no fish. And now you just have the majority of the marine iguanas dying, the majority of the Galapagos penguins dying, much smaller numbers of sea lions and fur seals where they don't have many offspring, etc. And so like being there, like, oh, I so get the El Nino and La Nina now. And with with climate change, one of the things we're observing is that El Nino years come more frequently and in greater intensity. So that's an impact that I didn't appreciate before I could actually see it. And like when you're snorkeling, you're swimming against the current. You're like, oh, like I get the current, like I can see it actually. And in other years, like it changes in how strong it is. So this was thought to be a subspecies. Now it's considered to be a species specific to the Galapagos. Yes.
Is the weather pattern always either El Nino or La Nina, or is there like a medium?
I think in the years where it's transition, it's not really strong one way or the other. And I think that there are some El Nino years which are bigger than others. Now, I should know that from living here because it affects us. Like even like when we measure like our temperature, like our temperatures are going up, but it's not a straight line. It'll be kind of like up and like, ooh, 1998 was super hot. And like El Nino and La Nina affects us too, but I don't think as visibly. And I never made a good connection until like I was actually in a current that I could see. But like I think in the transition as you go from one to the other, it's a little mild.
Periodically punctuated by either an El Nino or a La Nina.
I think I think La Nina is more the common one we typically see, and then it can shift to El Nino. My understanding. Sea lions are great. Like so. Like they're just hanging out, they're playing, and then there's a point where they'll play with you. Like they're just coming and they'll like come as fast as they can. You do think it's going to hit you in the face, and then at the last minute, like quick goes to one side or whatever, and you're just like, wow, like I went there hoping like, oh, I hope I get to see a sea lion. But once again, this is separated from Western South America. So we consider them to be a separate species. All right, so they've been isolated so long that we see they've changed relative to other species of sea lions. And there is a second one, a relative called a fur seal, also a native species. So here you can just see they have thicker fur. Their external ears are a little bit bigger here. Once again, that whole La Nina, El Nino, that affects them. When there's fewer fish, then they don't do as well there. It's harder for them to have litters of young, which are successful. They'll get smaller, etc. Okay. So there are Pacific green turtles, but it's thought that the ones in the Galapagos are a different species. Once again, the experts differ, but that's kind of the point, where if you start changing, it's this continuum, and at some point an expert's going to say, all right, let's say this is now a different subspecies. You change a little bit more, you said it's another species, but another expert comes along and says, nah, I would have put the lines here and here. And someone else puts it like where it's not obvious, where before Darwin, it was thought, oh, clearly these are all different species. They have been separate since the beginning of time. All right. So they're discrete. There's nothing joining them. Whereas now it's like, oh, like it's a continuum, and I can't tell where a subspecies ends and a species starts. So the reason that the way that we have trouble distinguishing them, that's actually kind of the point. And here you can see that current that I'm snorkeling against. So it's a La Nina year. So this current is coming from the Antarctic, and it's bringing all of these nutrients from the ocean bottom, which allows the algae to grow, which then allows the fish to eat them, which then fosters everyone else. And then it takes work. I mean, you're swimming against a pretty strong current, but then that would just the ocean currents would shift and go a different way in El Nino years. So these are big turtles. They'll swim right next to you, like they're just doing their own turtle thing. Um, and they're called green, not only because their shells look green, but in the old days, sailors loved them because being out at sea, they didn't have many sources of food. So if they found sea turtles, they would eat sea turtles. And the fat tissue was green. These turtles eat so much algae that it turns all of them green inside, including their fat tissue here. Right. Now, one thing I'm just going to guess, I can't say. Climate change may affect reproduction. So here you can see a trackway of a green turtle, which came out onto land, all right, overnight. It doesn't want to do it in the day. If it does it in the day, everyone loves to eat turtle eggs, even here. I mean, turtles lay their eggs, and all the chipmunks love it, the raccoons love it, the blue jays love it, the ravens love it, like everyone loves eggs. And so the turtles, if they don't do it at night, then they've just lost most of their thing. And here you can see the trackway. Here's where the female went over here to lay her eggs, and that's her trackway back. So she laid a bunch of eggs, and then she buried them. Interesting thing about turtles, though, is what determines gender? Well, for a lot of species, it's sex chromosomes. I mean, we have X and Ys, birds have Zs and Ws. That was kind of like the last talk I talked about. Half of reptiles, it's the temperature of the nest. So if we found some sea turtle eggs, and I gave you half, and you took them to your house, and your house is warmer than mine, your eggs might all hatch to be females, and mine might all hatch to be males. All right. So it's the temperature of the nest. And if you lay a deep nest, then probably there's a little bit of a temperature difference, so that like the top ones are going to be one temperature, the bottom ones are going to be another temperature. But the climate is changing so quickly that one of the consequences it could legitimately have is to change the gender ratio of sea turtles and many other reptiles, where there's far more of one gender than there would be of another. Okay. Now, as I go through the iconic species, I'd like to talk about Darwin's finches. Okay, now. First thing, I'm sorry, I'm going to get you angry, but I'm angry at this too. Everyone loves scarlet tanagers, but sorry, they're not tanagers. They're actually cardinals. And especially if you go to like Hawaii or down south or South America, there's something you would a type of cardinal. It's mostly white and gray, but it's got like a red little thing. Sorry, that's not a cardinal, it's a tanager. So what you call a tanager here is actually a cardinal, but then there's another thing that you could call a cardinal that's actually a tanager. These aren't finches, they're tanagers. All right. So when people used to classify birds, it's like, oh, it kind of looks like a tanager because of this beak shape. But now that we can compare all the genes, you can say, all right, so yes, superficially it looks like this. But when you compare the genes, clearly they're related over here. So Darwin's finches aren't finches, just saying. So they're famous, all right? And essentially it goes like this, where here is a finch. You can see its color, but look at its bill, all right? And then you look at this one. Look at that bill. Look how thick that is. There's like 18, give or take, species of finch. Once again, we can argue about species and subspecies in the Galapagos Islands. It only exists there. So somewhere there was an ancestral tanager that came to the Galapagos, and it went to this island and this island and this island. Now remember, the islands are different ages, so they have different types of vegetation. The oldest ones, like San Cristobal, has trees all right, and as you know, very different vegetation than the newer ones, which are only a little more than 500,000 years old. So, you know, the seeds you're going to encounter on one, like you need a thick bill to break them, etc. It's going to vary. So you've got different islands, and these birds adapt to different niches, especially since these are remote islands, you know, hundreds of miles away from the coast of Ecuador. So a lot of the other birds that would eat seeds or bugs in Central South America never made it to the Galapagos. So now there's opportunities that they wouldn't have if they were in the jungle somewhere. And so we have 18 different species of these, once again, showing that from an ancestral population of you know, these finches tanagers, they diversified to make many species just in the Galapagos. Darwin didn't pick that up though, because he didn't know that. Well, once again, Darwin's a young kid kind of at this point. Like he's piecing this together. Like this is going to be a journey. He's not going to publish for 19 more years. So a lot of like we look back, it's like, oh, didn't Darwin know this? No, he was like becoming the Darwin that we're familiar with, and his ideas on evolution were becoming. He would study barnacles forever. He would study pigeons forever. He would compare, you know, specimens, you know, all of this, trying to like make sense of all of this. And because in the 5 weeks that he spent in the Galapagos, he didn't quite get that the finches were important. He didn't really collect them. So when he came around to like, wait a minute, I think I missed something important there. He had to borrow from the collections of others, like the Captain Fitzroy, and others. So Darwin's finches beautifully illustrate Darwin's thinking, but they did not plant the seed in his mind. If anything did, it was the tortoises, maybe the marine iguanas, and a bird that I'm going to mention in a second, as unlikely as it sounds. So this would come later. So if you were to go to Galapagos, it's like, oh, here's all the species of the quote Darwin's finches, and here's the islands that you can find them on. Now, as you might imagine, these are little islands, and if you're going to be only on a couple of them as opposed to all of them, a lot of these could be in danger of extinction. So I mean, look at the bill on that one. That's amazing. I love that. Um, and so they're in trouble, a lot of them. And one of them, just here's a thing. We worry about invasive species. All right, here, and that's I could get into that. But here's just a horrible example of this. There is a fly that was introduced to the Galapagos where it lays its eggs in the nostrils of baby birds. And then the larvae then develop there to the point where the birds have trouble breathing and they die. And so a number of these birds, which had small populations to begin with, this is this might push them into extinction. Like the people who are trying to figure out how to save these species of Darwin's finches that only live on this island. I talked to some of them and they're just like it's not hopeful. Yeah, just like this is a really tough thing. And the Galapagos knows that they have a lot of things which only exist there. So they're careful. It's actually hard to get fruit in the Galapagos because you just can't ship things from Ecuador because they're afraid of bringing stuff in. But this fly apparently can lay some of its eggs under the surface of fruit. So like they would inspect fruit, but this could have actually been in the interior of the fruit that came in. So just invasive species are just a real challenge. And here's just a classic example of that. Okay. Couple more examples. So if you're going to be on dark rocks, then having a dark color is key. And there are what are called lava lizards. Okay, there's a couple of species of those. One is pretty common throughout the islands, but then there's a couple which are only on this island or that island, and they only exist in the Galapagos. So once again, once upon a time, a lizard got to the Galapagos and developed into these lava lizards and the diverse kinds here. So here's just the lava lizards, but you could do this with a lot of the things that I have mentioned. So I have different colors for the different species of lava lizard. All right, and so you can see the islands where you could to find them. Once again, like Darwin was looking at stuff like this, he's like, this doesn't make sense. Like, why would there be the creation of a species just for this island? Why would there be this species when the species are so similar to each other? And I realized it makes more sense if, from one ancestral lizard, they got to these different islands and then changed into the species that we saw. Once again, that's not as dramatic as like what we think of. But remember what his book is. His book was titled The Origin of Species. To us, saying that a pigeon evolves from a dove, that isn't that controversial, but in his day it was. All right. And so for him to say there is a natural way that Earth can have a new species that it didn't have before, that was a completely different way of looking at life on Earth, the idea that it could change. The penguins which exist in Galapagos only exist there, and they're primarily in these islands, which is what's getting those cold currents. So the cold currents don't hit all of the islands equally, so they hit here. So that's where you're going to have most of the fish, and that's where you get the Galapagos penguins. The ocean waters are a little warmer around the other islands here, but you can see them on the rocks, etc. Once again, La Nina years, they love La Nina years. In El Nino years, they really suffer. And then you can go snorkeling and, oh, there's the penguins swimming right in front of me. Galapagos mockingbirds. This is probably one of the videos which would interest you least. But it was this and the tortoises which planted the seed for Darwin. So if you ask, like, what made Darwin think that I think things change over time, it was the tortoises, and believe it or not, it was these. The fact that you had different mockingbirds on different islands. So this is the most common one, but by the time I got to one of the later ones, this is a different species of mockingbird that only exists on some of the islands. Right now, so any of these things could have been the aha moment for Darwin, but believe it or not, it was the mockingbirds, one of the two big ones. These guys look sad. I mean, look, their wings are so puny, they can't fly. So these are like the cormorants, which we have, but these are flightless cormorants, all right? They only live in the Galapagos. And then you realize, oh, wait, no, that's actually a good thing. Because if they had normal size wings, flight feathers trap air. They want to eat fish, so they want to like dive after the fish. And if you dive and you've got these feathers which are trapping air bubbles, that limits how fast you can swim and limits how deep you can go. These guys don't need to fly. They're endemic to the Galapagos. They're not going anywhere. And flying would then make it harder for them to eat. All right. So the loss of the reduction of their wings actually, don't feel sad for them. That actually is a factor in their successfully hunting here. We could go on. I want to get back to the boobies for a second. But there are doves, which are native to the Galapagos that you can't find anywhere else. There are hawks. Well, the Galapagos hawk is native to the Galapagos. You can't find anywhere else. Lava gulls. Look how dark they are. All right, but once again, that same thing. If you're trying to blend in with the black volcanic rock, especially on the younger islands, that would certainly help you. I don't see the need to go into to all of these, but obviously, like, I'm a little biased. I've been focusing on like birds and reptiles, primarily. There are bugs that you can only find. Here's a carpenter bee that only lives on the Galapagos. Here is a ladybug that only lives on the Galapagos. Here's a scorpion that only lives in the Galapagos. So I don't intend on going into in invertebrates in great detail. We could do the same with plants. There's a whole bunch of plants. So over a third of the Galapagos plants, over 600 species, aren't found anywhere else in the world. So here's some cactuses growing to the size of trees. Here's another cactus. And when I look at this cactus, it's actually the way that lichen would be one of the first things to colonize bare rock. In the Galapagos, this cactus kind of does that. It acts like a lichen. It's a pioneer species. When you look at this, you can say, oh, this must be an island that doesn't have tortoises, because tortoises are vegetarians. They would eat something that was that low to the ground. A lot of the cactuses which live on the islands that have tortoises, look, they form little trees so that the tortoises can't reach them. Here's a red, I think it's called Galapagos carpetweed, right? But we could go into all of the plants of the Galapagos, et cetera. Okay. Yeah, I'll mention the fish last. Yeah.
Anything about snakes at all? No snake coming out?
I did not see any. So I just always show videos that I've taken. All right, I'm gonna say it. I hate to say it. I'm gonna have bad dreams for like. Has anyone ever seen? I think it was David Attenborough narrating it. The thing with the snakes on the Galapagos.
Yes.
Yeah, terrifying. Oh, like it's like I'm sorry, no Friday the 13th is anything like this. So what it is there's these marine iguanas. They are hatching out of their eggs, and you can see the ocean. If they can get to the ocean, they're safe. All right. So you see them, they're coming out of their eggs, out of the sand. They just have to get to there. But all of a sudden, you see out of all the rocks, you see the snakes come. And then they just all go after them. And you see the lizard running, the little baby lizard, and it tries to freeze, and the snake goes by, and then tries to run a little bit more. If you see it, it's terrifying. Well, like, oh, like my blood pressure went up so much. So there are snakes in the Galapagos. I did not get to see one. Not that I know of. No. Yeah. So there are three types of boobies in the Galapagos. They are not specific to the Galapagos, although this is one of the major places where we can or see them. I'm sorry, I got so upset by the snakes. I lost where I was. I'm sorry. There we go. All right. So the most famous one or the blue-footed boobies, but there are red-footed boobies and Nazca boobies. You'll see all of these. So what they do is algae have pigments, right? That's just like plants are green to soak in light. Algae have pigments, and then a lot of the invertebrates that eat the algae then get the pigments in them, so with the little fish. And then these birds say like, "Ooh, I just ate pigments." And like birds out here, they say, "Ooh, I could now put pigments." Most birds put in their feathers, but they actually put them in their feet. All right. So they don't make these pigments, they eat them. If you change their diet, they would have gray feet. All right. Or if they weren't as healthy, they would have gray feet. It's only healthy boobies that can make the blue coloration. Which we associate here. These are diving birds. So they'll just circle, and then they'll go at a certain point, they'll dive, hoping to catch a fish. All right, we'll see this happen sooner or later. So there we go. So if you're just by the coast, you can watch them all doing that. Here, when they're young, they have that gray color. So if this were unhealthy, it would have a gray feet. But this is just young, just hatched that year. If you go around, literally, there's one of the islands where like you stick to the trail and you're like, oh, there's nesting boobies right there. Like, oh, there's another set here. Like, so they're if you go to the Galapagos, you really get wildlife close up. This, I'm not quite sure what happened to this infant. It died, like maybe it got sat on too hard here. So here's an adult sitting on young. In my song, I mentioned something that this happens a lot with birds where like if 3 eggs are laid, the third egg is the smallest and is the last to get food. It might not make it if there's not that much nourishment this year. In the boobies, they can fight with siblings and even kill them if there's not enough food. And for whatever reason, Nazca boobies always do. Nazca boobies always lay more than 1 egg, but only one survives because the one kills the other. So the biggest. One of the things that makes the blue-footed boobies famous is, I think we'll see it there, but I think we'll see it here even more, is so here we see a male and a female. The females have darker blue feet. The males are lighter blue, so you can kind of tell who's who. And remember that this is coming from their diet. So if you're trying to meet a prospective partner and you show them your feet, they're getting a look at how healthy you are. They're like, ooh, look how bright blue this one's feet is. This one's eating well. These must be good genes to pass on to my offspring. So as they go, look, they're literally just show, look at my feet, look at my feet. And you can see them courting here, and all of these. This goes on for a while. All of my playlists, they're on my YouTube channel at Dr. Jan 41. So if you went there and just typed in Galapagos, you could watch the full version. That's the male with the lighter blue feet here. Okay. But there are others. So there's the red-footed boobies here. All right. Now you won't see them on as many islands. They're more on the eastern islands facing Ecuador here. So I only got to see them on one island here. And then somewhere there are Nazca boobies. Let me just show the last species here. Once again, I only saw them on the last island here. So they've got black and white and more of a yellow. Yes.
Yeah.
Same thing. So what it is so great question. There are berries here everywhere, and all these birds are eating the berries. Cardinals take carotenoid pigments out of that and make red feathers. Baltimore Orioles take carotenoid pigments out of the fruit they eat and make orange feathers. Goldfinches are taking yellow feathers. So how you take dietary pigments and incorporate them in the feather production depends on your genes. And just, you can have birds in this area eating some of the same fruits, but still then have different colors just because then the genes that they use to incorporate pigments into their feather production can vary. So the same thing here. They're taking pigments from what they eat and putting them in their feet, but how they do it, especially since blue is not a pigment that birds make. Usually what blue is the microscopic structure. Like if you take bluebird feathers and grind them up, they look gray. So it wasn't a pigment that made it look blue. It was the shape of them and how it refracted light. So I was told that if you take a blue-footed booby's feet and you just kind of like crush it, not like hard to hurt the bird, but you just kind of like, squeeze it. Now it looks gray because it was the microscopic structure of the tissue that refracted light in a way. So it's whatever genes they're doing after the pigment incorporation, but they're both getting it. They wouldn't have either red or blue if it wasn't for what they were eating. Now I should wind down, but just I'll give a shout out. Then there's all of these other things. All right, so like obviously the oceans are full of great things like humpback whales and other types of whales. So once again, there's only specific areas where it's cold where you're getting the current. So you can't see humpback whales everywhere, but like you would know, like if we're going to see humpback whales, it would be here by Isabella Island between that and Fernandina. We're not going to see it on the other ones here, but you can see them. So seeing whales is always fun. And this would probably be another talk. But then there's all of the marine life you would see. You don't really have coral reefs the way that you do here. It's mostly rocky. So the diversity, like the Caribbean, has prettier reefs and prettier diversity than the Galapagos does. This was huge. Like, so I saw the snorkeling and I'm like, ooh, like I'm going to swim after. Like I don't know if that's a good idea. Like I don't know if you can get hurt by these things because they can be like, I mean, you can see how big they are. They're like can be like 9 people. But we swam after it anyway, and we lived to tell the tale. But this is a array just huge, huge. But once again, if you have ever gone snorkeling in Florida or in the Caribbean, and then you go here, you realize, oh right, there's a separation. Like these Caribbean fish, they can't get to Ecuador and vice versa. So just like geographic isolation can give you different species of birds or tortoises or whatever, the same thing with fish. You see different fish in the Pacific than you do in the Atlantic and the Caribbean. And then you can see different fish around the Galapagos than elsewhere. I don't think I saw too many fish which were just only in the Galapagos. I think this is the only one and it wasn't that great. This is what's called a dusky chub. All right, but this species is around the Galapagos, nowhere else. And then I have others, but once again, these, if you know Caribbean fish, you can say, oh, I've seen parrotfish. Oh, but yeah, but this would be a different species. Like, so the Pacific would have different species from the Atlantic. Something in the chat? All right. I wish they would repeat the question. Oh, okay. They put his information. Yeah, he said Dr. Jan 41. So if you were to go to, right. So I'm sorry, let me just answer this question here. All right. So you can go back later and look at Miley Cyrus if you want. Right. So my YouTube channel is at Dr. Jan 41, DRJAHN 41. And I have lots of playlists for the classes I teach. But if you were to just type in Galapagos here, here's the playlist that you've been seeing here. So you could get there. So if anyone said like, oh, like I would have liked to have seen that, great. That's how you would go there. Okay. So, so Darwin travels the world, all right, but seeds were planted when he was in the Galapagos. That this is not how life started, all right? If you went back in time, life didn't look like this. There were other species that then changed into what we saw. And once he looked at it from that point of view, he could see evidence of that everywhere. Like when we think of cats, we all think, oh, cats are related. We put them in a family. You know, like once there were ancestral cats that gave rise to all of these. Dogs are related. Bears are related. Warblers are related. That's a new way of looking at life. When at the time of Darwin, most people held that each bear was 100% distinct from the others, as unrelated to other species of bear as they were to trees or to bugs. That if you went back to Earth when life started, there would be like every kind of bear, every kind of cat already there, that they were not biologically connected in any way. And so the Galapagos Islands, you know, clearly, you know, just a beautiful place to visit. You know, any place where wildlife actually comes up to you instead of you having to like, you know, chase it down. I mean, that's a joy. But when I asked the question at the beginning, like who was surprised, the fact that none of you were, Darwin's 5 weeks in the Galapagos changed how we see biology so dramatically that, you know, kind of the ideas that Darwin came up with, or like he spoke of, once again, it goes back to the early Greeks. I mean, there are examples of people being killed for that stuff. All right, or like forced to recant, or like under threat of excommunication, and then, you know, books, you know, like you got in trouble for doing this, and now I say it, and you're like, yeah, of course pigeons came from doves, of course this. So, you know, Darwin's ideas, once again, large part, you know, seeds planted on the Galapagos, have just become fundamental in connecting the fields of biology. So I hope this was informative to you. I hope you like the wildlife, but also trying to see just how critical, you know, these islands. I mean, it's a big place. There are lots of islands, lots of wildlife, but this wildlife had a special role in molding how we see the world. Yes.
Oh. It discovered those islands.
Oh, it was, well, so the British sailors before Darwin were there. There's a movie, I'm not going to quote the movie, but there's a movie about some British sailors who get there first, and then like, so Darwin comes back there. I don't, I think some sailors who wanted, and we'll get to you in just a second, sure. I think sailors who were always looking for food to keep them on these long journeys, I think at some point the Spanish figured out that you could essentially just take tortoises. I think they just hung them in the rungs like underneath the ship, and they would use them for food along their voyages. So I think it goes back a ways. I honestly don't know if people from Ecuador got to the Galapagos prior to that. I don't know that they, like, obviously this is one of the 4 provinces of Ecuador now, and so, you know, thriving, you know, communities, part of Ecuador live there now. I don't know. I don't think that they got there before, you know, the sailing ships. Yeah, and I'm sorry, you wanted to add.
I'm going to say that I did a little research.
Oh, okay.
And Friar Thomas de Belanga, I'm not sure if I pronounced that properly, but he was going from Panama to Ecuador, to actually Peru, and the currents and everything got him sidetracked, and he ended up on the islands. He is credited for the first person to actually discover them.
Oh, okay. If you're at home and can't hear that, so there was a gentleman. Is there a year on that?
1487.
So in 14.
When he was born. I'm sorry.
Oh, okay. Okay, so sometime, you know, around 1500, give or take, someone was trying to get from Panama to Peru, and the currents took them to the Galapagos, and they might have been the first person to set foot there. Thank you very much.
Here it is, 310, 1535, I believe.
1535. Thank you. Thank you very much.
Check that out.
Yeah. Oh, yeah. No, I was there. That wasn't part of our, or I wasn't paying attention. And
I also have a
Sure.
comment about, I don't know if this was a problem in the discussions of evolution and theology, but Teilhard de Chardin.
yeah.
You
Yeah.
probably, the church was still arguing that problem
Mhm.
in the 50s.
Mhm.
With his research. He was an evolutionist,
Mhm.
but a theologian,
Mhm.
right?
Yes.
So you
Yes.
know about it.
I do. I do.
I wasn't going to bring him up because we're not doing theology here.
Mhm. Well, but so one of the things that it's obviously I certainly not my place to here's what I think on the thing. But I also, but you should be encouraged in that, like, this was the first thing that we have record of people arguing about. Like, the first philosophical argument was evolution versus design, and it still comes up in textbook adoptions today. So like we should discuss it, and all of this. So by all means. But thank you for bringing that up.
I took some theology courses when I was very young,
Mhm.
in my 20s.
10 years ago.
Thank you.
Okay. Thank you so very much for coming. We're going to look at Latin America with Paraguay, Costa Rica, and mainland Ecuador. I lived for a long time in Paraguay, but I didn't have a good camera when I was in the Peace Corps. I was poor. So anyway, I'll do the best I can. But that's next week. Then a bunch of national parks in Florida, the Everglades, the Caribbean, and then scuba diving at coral reefs, and then a look at the Southwest United States. So I'm wrapping up, but someone online said they had more questions, so I'm going to answer that for a little bit, and if anyone wants to stick around and ask questions, you're welcome to. So in the chat, you said you might have questions, so what questions? Oh, okay, so this was about the course. Okay, so one of my students is sitting in on this, but has a course question. So I think that's it for, unless you want to. If anyone has questions about the quizzes too, you're welcome to just stay. Thank you for coming. And once again, if you're looking for nature walks with nicer weather, 4 o'clock tomorrow at the 6.5 station in the Heritage Trail, and 10 o'clock at the Bash.
See you tomorrow.
See you tomorrow. Wonderful. Great to see you. Okay, so if you wanted to ask the questions about the quizzes or whatever, I'm going to stop recording. I do have to run. I have to